Hello, everyone. Please let me know if you can hear me. Hello, everybody.
No, cat.
Hey, hi. Okay, thank you. Now I know that people can hear me. Do you know I've been shouting since I never knew the meeting has not started yet. And I've been saying hello, hello. Can you hear me? Oh my God. Ah, okay. Good morning, good morning, good morning, good morning, good afternoon, good evening, wherever you are hearing us from. My name is Benga Adeyemo, and I'm the community lead for the Winnipeg Power Platform User Group. It's a user group where we usually share ideas, where we come together to collaborate. Um, since October last year, we started this Power BI PL 300 training. We've been doing that since October last year. We usually meet every Wednesdays and Sundays, 8 p.m. CST time, and it has been fun. People have learned a lot, we've shared ideas, and it has just been fun all through. This will be our first general session in 2025. Last year we had a couple of speakers that we invited for so many sections. Like we had sections majorly on almost all the Power Platform tools. We had section on Power Automate with Power BI. We've had Power BI sections. We've had Power Apps. We brought an expert to come and build a Canvas app, and which was really really fun, and people really learned a lot. Uh, we're starting this year on a very good note, and we are starting this year with Power, because Power BI is what the community members say they want us to be. You know, they want us to be treating for now. So that's why we are sticking to Power BI for now. But very soon we'll start. We'll round up the Power BI sections that we usually have, and maybe by April, May, then we start Power Apps fully, and also we integrate Power Automate also, right? As time goes on, as people keep growing in the community, you're also going to, introduce some other tools like the Copilot Studio. Try to have more sections on data vars, and all of. I'm using Copilot for Power Platform generally, right? Interesting. So today we have our guest speaker, who is somebody I've known for years now, and I know his capability to be very, very sound. He has a very good in-depth knowledge about Power BI, not about Power BI alone, about almost everything in Power Platform, and even in data engineering. And not to waste our time, not to waste any time at all. Let me just introduce our speaker. His name is Tunde Morakinyo. He's the lead business intelligence at Bazara Tech. He's an international consulting firm where he's leading so many projects ranging from different customers in banking, oil and gas, and customers from different sectors, helping them to build scalable solutions that we actually influence their decision making, and also help in improving their operational efficiency in general. So, not to waste time, let me call on Tunde Morakinyo. He has so many certifications. So he's a certified fabric analytics engineer, Power BI data analyst. He's a Microsoft certified trainer. In fact, I don't even know what to say again. He has so many qualifications. So today, you can take the floor now.
Right. Thank you, Benga, for that warm welcome. Please confirm you can hear me clearly.
You are clear, but I want
Okay.
others to respond in the chat section.
All right. Okay. I think there are thumbs ups. That signifies they can hear properly. Okay. Sorry. 1 second. Okay. So without wasting much time, let's just dive into the business of the day. I'm going to share my screen. Um, okay. Please confirm you can see my screen properly.
Yes, clear.
Okay, awesome. Once again, Benga, thank you very much for having me today. It's a pleasure. So for the next couple of minutes, 1 hour or thereabouts, we are going to be talking about Power BI circular dependencies, and we are going to be diving into its intricacies and also provide practical solutions and best practices to prevent its occurrence in our Power BI data model. But before we go into the main thing, I'm just going to run us through the itemized content summary. Okay, right. So the first thing we're going to be talking about is understanding circular dependency and why it occurs. We are also going to look at how we can identify circular dependency issues and also look at how we can resolve circular dependency problems as well. And after which we are going to look at best practices to avoid circular dependencies. We are going to be deeping dive into calculate functions and how it affects calculated columns in the context of circular dependency. Then we jump into demo examples and wrap it up with key takeaways and next steps for us. All right. So let me quickly ask this question. Has anyone ever gotten an error that reads circular dependency was detected, maybe while you are trying to compute calculated columns in Power BI, especially with DAX, or perhaps when you are trying to establish relationships between tables in your data model? Anyone?
I think I've experienced it before years ago, but I never understood what it was.
I think in the early days of my career, I experienced it a lot working with Power BI. So I've always wondered what is the circular dependencies and all of that. If you have, you must have asked yourself, what is this error about? Why have I found myself in this situation, right? Typically, to be honest, when you have two or more tables or two or more columns reference each other in a way that form a loop, circular dependency will always occur. So we are going to be looking into the in-depth meaning of that circular dependency in future slide. And what I'm going to talk about now is how we can identify circular dependencies really. So circular dependencies can be identified in two ways. Power BI always, through these error messages that a circular dependency was detected, and also going to give us the details about the tables and the columns involved in that error. And as well, model relationships by reviewing the model relationships, checking calculated columns and DAX formula for loops, and using tools like DAX Studio and Tableau Editor to analyze dependencies. Those are two of the external tools that you can use in Power BI. So you can quickly identify, even by the time you are dragging relationship between one table to the other, Power BI, if circular dependency exists, it's going to throw you that error message, right? When we see this message, what do we do? How do we resolve circular dependency issue? Number one is to break the loop. And what is this loop itself? Loop is about circular reference, when columns reference themselves in a circular manner or in a cyclic manner, let me put it that way. So I think I've provided something that I'm going to use to explain this better in future. Maybe by the time we get to the practical aspects, I believe you're going to understand better what loop is all about. And one of the things you can do is to avoid referencing calculated columns in another calculated columns. You take, for instance, you have your price table and your quantity table, and you want to compute your sales amount, which is the product of these two columns, right? You create a new column, you start referencing different columns to compute, this new column. And you now have another column that you want to compute after that. So you have to, reference the original column that you created. You should avoid that, right? And another one is to use calculated measures instead of calculated columns. This is very, very important as well, because it's going to help you performance-wise, right? In terms of your Power BI data model performance, and it's not going to stress you, to be honest with you. So any calculation that you want to compute within Power BI, you should always think about computing them with measures first before thinking about computing them with calculated columns. And another thing I'm going to talk about is bidirectional relationships. Avoid bidirectional relationships as much as possible. Always ensure that your relationships are single directional or unidirectional, as the case may be. This is going to save you a lot of headache or circular dependencies headache. And another thing is just to simplify your relationships within your data model. You can use something like bridge tables to actually resolve a many-to-many relationships between two tables. Or you can also leverage a role-playing dimension, which is a single dimension table that serves multiple roles to avoid complex relationships. So these are the steps you can take. And you also want to ensure that you use DAX functions carefully to avoid self-referencing in calculation columns. So this is going to lead us into best practices that we can adopt in order to avoid circular dependency issues. So I've itemized 4 here, and as you can see on my screen, we have the number 1 there is use star schema design. When you are designing your data model, it is critical that you organize your data into fact and dimension tables and avoid creating relationships between dimension tables themselves, because these are the things that could easily cause circular dependencies. And as a matter of fact, the Vertipack engine that Power BI runs on is optimized for star schema. So you can always be rest assured that when you adopt this star schema design, your Power BI model is going to be greatly optimized. All right. So the second one is to prefer measures over calculated columns. As you can see, measures are dynamic and don't create dependencies in the data model. And apart from that, when you compute calculated columns, it adds data physically in memory. What does that mean? You create multiple calculated columns, it adds to the size of your data model. And this is very dangerous because when you refresh your data, right, the calculation will recompute every time you refresh your data. So, and this is not good for your storage engine, right? But for measures, they just, run at query time. They don't really add to the size of your data model. So always prefer measures over calculated columns whenever you want to compute calculations in Power BI. And the third one is to avoid self-referencing. So you can ensure no column references itself directly or indirectly. And the fourth one is to validate relationships. As you are building your model, always validate that they are single directional, because sometimes you drag, a fact table column, which is a foreign key, onto a primary key in a dimension table, and you realize that out of the box, Power BI actually created a bidirectional relationship. You should always check that out just to make it a single flow, from the dimension table down to the fact table. That is the ideal way. So without wasting much time, we are going to be diving deeper into calculate, right? And how it affects calculated columns when it comes to circular dependencies. You agree with me, if you've been working with Power BI before now, calculate is one of the most popular DAX functions, and it's arguably the most used, right? It is a very cool function, and it can make and mar your data model. I can tell you that. So the calculate function in DAX can introduce context transition. I don't know if you've heard that buzzword before, context transition, but I think there's a video that Benga made that actually explains context transition. I think we should watch that video. All right. So this context transition, when you use it in a calculated column, can create what we call implicit dependencies on other columns or tables. And if these dependencies form a loop, definitely circular dependency will occur. And let's break these 3 steps down a little bit. Context transition, what does it mean? Okay, where you convert a row context, a row by row computation of calculation into a filter context with the help of calculate, right? It forms what we called a context transition. So there is no context transition without calculate. Calculate function is the one that forces a row context into a filter context to form that context transition. So when you use calculate anywhere in your calculated columns computation, context transition is going to occur, right? And the way it works is that it makes the column that you are computing dependent on every single columns in the table, which means that when you create another calculated column, you are likely to experience circular dependency, right? And we'll be looking at how to resolve this in the next slide. And we are also going to have a practical session on that for us to have a better understanding of how it works. All right. So please take note of this. All right. And how do we solve this issue of calculate being used in calculated columns? So the one thing that is sure is that let's just avoid calculate in our calculated columns. We can always use other functions. Maybe if you want to apply filter, we can use a filter function. If you want to apply further filter, we can use functions such as street as and all of that. If you want to compute row by row computation and sum them up, we can use iterator functions such as sumx. But we can always avoid calculate. And if we must use it, we need to ensure that that column does not depend on every other columns in that table. We're going to be looking at that, like I said earlier. So the second one is to restrict column dependencies. So you can avoid circular dependencies by restricting the list of columns that the calculated column references, when you're computing your formula with calculate, right? I told you can use a function, so some functions like all except, remove filters. Those are calculate modifiers that you can use to restrict this calculate to filter every other columns in your table. The only thing that you can reference or you can filter is a primary key. And you also have to keep in mind that using calculate in calculated column is very dangerous, especially if the table has no primary key. And this is because context transition itself will likely produce unexpected results or figures if you do not have any key column in your fact table. You can have something like If you have a fact table, a sales fact table, you can have something like a sales ID that uniquely identifies each of the sales transaction. So you can leverage this particular column. If none exist, please do not use calculate in your calculated column computation. All right. Do we have any questions, or is after the entire thing, Binga? Is the question period after the entire presentation, or they can ask questions in
People can
between?
actually ask questions in between. It's supposed to be an interactive section. You can
Okay,
ask you
great.
questions in between, so they don't have to wait till after the whole thing.
Okay, awesome. So if you have any question thus far, let's just ask so that I can provide answers to them. Because what we are moving to next is just to look at how we can practicalize this in a demo and show us how this works. Any question in 30 seconds? Does that mean that we all understand what I've been saying about circular dependencies?
If there are no questions, just go ahead. Sorry.
Okay, awesome. So let's just quickly look at how we can demo this. I'm going
Some people are just
to
waiting for the demo. Maybe they don't understand all the big grammars.
exactly. I get. To be honest, I get. So let's look at that. I'm going to just share my Power BI right now. 1 second, please. Yeah, please. Is that up yet? Can you see that?
Confirm.
Okay, all right, great. So I already have some data loaded in my Power BI data model. And if you look at my model view, I have a sales records, which is a fact table that keeps the record of every sales transactions. And we also have a dimension product table, and we have a product category table that also references the product records. This is like a snowflake architecture, right? If I go to the table view, we see we just have a few transactions, 20 transactions, and you can see we have a sales ID that uniquely identifies each of that transaction. We have the product in questions, we have the price of the product, the quantity, and the transaction date. And for the products, we have 9 products exactly, ranging from laptop down to washing machine, and we have the category each of those products belong. And the product category table are just 3: electronics, accessories, and home appliances. So we are going to be starting from this sales record. Out of the box, we do not have sales amounts, and we've been tasked to compute maybe products by sales, or maybe top 5 or top 10 products by sales. So we need to compute something. We need to compute for sales amount. How do we do that? We can create a new column, just create a new column here. Let me see if I can try to, just try to increase this guy so that we can see properly. Okay, great. I think that works. So we can say this is our sales amount. These are sales amounts. We can easily just reference the price and quantity and say this is our price multiplied by our quantity, and this gives us the product of these two columns. But we are not going to be doing this this way because of what we are trying to achieve. We're going to be using iterator function called sumx, right? And instead of this, we can always leverage sumx to say sumx go into every record in our sales table and multiply the price and the quantity column. So you can reference this, the price, right, multiplied by the quantity. And what this is doing is that it's multiplying each of these transaction price by its quantity, 1,000 by 2, 800 by 1, 600 by 3. And when we hit enter, we'll see something strange. You see that in every row, it's just giving us the total. And what is this 22,150? It is done computing it, multiply this by this, each of the row, price row by the quantity, and it sums everything up to be 22,150. But this is not what we want, right? We want to be able to see 2,000 in the first row, 800 in the second row. It's because we've adopted the row context approach, right? And as a matter of fact, row context happens in calculated columns. That is where you can find row context. We need to convert this into a filter context. And how do we do that? That is where calculate comes in. Calculate is that powerful that is going to transform this calculation, this row context, into a filter context. And what do we need to do exactly? Just wrap calculate around our calculation, and voila, it's going to compute properly, as you can see. And in this calculated column, context transition has already happened. Why? Because you've transformed your row context into a filter context with the help of calculate. You know, I told you when I was presenting my slide that calculate helps you to create context transition. And this is an example of what I was trying to say. Now, and I said something when I was presenting that slide that when context transition occurs in your calculated column, or you use calculate in your calculated column anywhere at all, that is going to force a context transition. And what that means is that that particular column, this sales amount column, is going to be dependent on every other columns that you have in this table. I think someone is raising a hand or his hand, Binga.
I think they can unmute themselves. Let me.
Okay, I think that's Miriam.
Miriam, can you please unmute yourself?
Yeah, thank you. I want to know why you use some eggs in the first place to multiply the price by the quantity rather than just multiply it straight up. So why do you need to use that function?
Very good question. You know, before I started using SumX, I did something. I just directly referenced the price and the quantity, and it gives us what we want, right?
Yeah.
We shouldn't be doing it this way, actually, but I was getting somewhere. I wanted to explain what context transition is and how it happens. That is why we are going through this approach. Under normal circumstance, all you need to do is just to reference, your price and your quantity directly, and you have your figures. But there are some calculations that you are going to compute. Maybe you want to apply filters that you need calculate to help you, right? Context transition is still going to happen in that column. So take this as not ideal. Is that clear?
Yes, thank you.
Okay, awesome. Okay. So now, this sales amount column is dependent on every other column from sales ID to product ID to price to quantity to sales date. The way it works actually is context transition looks into each column. Okay, let's take the first row, for instance. It looks at the sales ID. Okay, this is sales ID 1. This is product ID 1. Okay, the price of this product is 1,000. Okay, the person purchased 2 quantity, and the transaction date was 1/1/2023. And it leverages all this information to compute this particular output, right? Now, what happens when you do something like you want to create another column? Maybe you want to apply some discount to some sales, and that's an assumption. Let's try to create another column, right? And let's call this discounts. And our assumption would be that every sales greater than 1,000 will apply maybe 5% discount. Otherwise, there is no discount. Okay. So let's compute this calculation, and it's pretty simple. We can just use a conditional if function to do this. And I'm going to say, okay, if the output of the sales amount, which is our sales amount, if it is greater than 1,000, we want to apply 5% discount. And we can make it dynamic. We can just say 5% is 0.05, right? 0.05 multiplied by the sales amount itself. All right. Otherwise, we just want to give it 0. So we don't want to add code that. We just want to make it dynamic as well and change this to a 0. Great. So what this thing is going to do is that it's going to look at 2,000. 5% of 2,000, it has to compute in this row. And 5% of 800, it has to that's compute here. And when you hit enter, something strange is going to happen. Voila, a circular dependency was detected. Wow. What is this circular dependency? And you can see the dependency, the column dependency. It ranges from sales record, sales amount, which is the one discount is referencing. It's telling us that the sales record sales amount is referencing sales record column, which is the discount amount that we're about to compute. And the sales record column is also referencing sales amount column. This is referencing this. That is logical. But it is not logical for it to say that sales amount that already exists has a dependency on the column that we've not even created. It doesn't make any sense. But that is as a result of context transition, right? And that's just one example. So I'm going to go through another example before we now start looking at solution, right? Let's assume this doesn't exist. I'm just going to comment this guy out and it's okay. I'm not going to delete the column. And let's say that we were asked to compute the total sales for each of the products. Let me take product ID 1, for instance. Product ID 1, you can see we have 3 transactions for product ID 1. And if you look at the transaction dates, they are different. But if you sum up the amount, 1,200 to 3,300 to 2,000, that gives us 6,500 just for product 1. So we've been asked to compute the total amount for each product. We can leverage our product table. If we come here, our product table is unique. We can just say, okay, for product ID 1, which the product name is Pro Laptop, we want to see 6,500. And for smartphone, we want to see the total transaction, sales transaction for smartphone as well. How do we do that? We can easily create a new column in our product table to say, oh, we want to call this something like product sales or anything at that. Then we are going to be referencing, because this has an existing relationship with the fact table, which is our sales records. We are going to be referencing that with the use of a related table function. And because we are on the one side of the relationship, we can only use related table. But if you're on the many side of the relationship, you use something called related, right? Those are relationship functions in DAX, right? What do? We want to do a related table, right? Want to do a related table sales record. This is, okay, they are related together, fine. So what are we trying to compute? we want to compute the sum of the sales amount column in the related table, which is sales underscore records. And we can now leverage SUMX because we are iterating over that table. The SUMX is going to suffice here, right? And what table exactly are we trying to sum? We're just going to sum the sales record, sales amount column, just right here. And this is what we need. And when you hit enter, you see that it computed the correct value. For laptop is 6,005, for smartphone is 4,003. Now we have this. Let's take, for instance, that we are now asked to maybe compute the percentage contribution of each of the products, such that in my fact table, I want to see for each of the products, product ID 1, like we've been using, we want to see 6,500 appear so that we can divide each of the transaction by 6,500. And it's going to give us the percentage contribution of each of these transaction value. All these are just assumptions. What do? Very simple. We can just leverage this value here from our sales record and create a new column to say we want to call this percentage contribution. We just want to do a related because this is related to the product record. Don't forget, when I was trying to sum up every transaction from this table, from the product table, I used a related table because I said on the one side of the relationship, if you want to get anything from the many side of the relationship, you are going to use a related table. But on the many side, you are going to use related, right? So related product records, and the product sales that we computed. And this should just give us, right? But what do we have? We have a circular dependency issue. I think someone has a question again. I see someone's hand up.
Just unmute, unmute, please.
All right, thank you. I want you to please take that again. That if you want to use related table in a particular case and you use related in a particular case. So I didn't really get that, please.
Okay, awesome. So, when I was trying to compute the total value for each of the products from our product records, which is our dimension product table, and I wanted to sum up every transaction for each product so that it can sum up in just one row, I used a related table. If you try to use a related, even IntelliSense is not going to bring it out because it's not going to work, right? So on the one side of the relationship, if you want to compute value from the many side, you need a related table. On the other hand, if you're on the many side of the relationship, which is our fact table, and you want to reference any column from the one side, you need a related function, just like a VLOOKUP. And there's another function. I think Benga released a video this morning that speaks to this. I think you should watch that video. You can either use this related or you use a lookup value, right? So if you're on the many side of the relationship and you want to reference a particular value from your one side of the relationship, you use a related. Otherwise, you use a related table. Is that clear?
Yeah, it is. Sorry, can we just say the fact table we're using related, then the dimension table we're using related right?
Table, exactly.
Related
spot on.
But
so
it's
in this example
also depend. Okay, Benga.
Okay, sorry. In this example that Tunde just gave us, it's very straightforward. So you see that Tunde it was on the product table. When it was on the product table, he used related table, and product table is the one side of the relationship because the product table is the dimension table that has a unique list of all the products and their attributes, right? But when today is now in the sales table, which is the many side of the relationship, because one product ID will appear several times, right? And today is now using related, right? Related is what we, so The two functions, related table and related, they all work when there's a relationship between two tables. So you are aggregating something from another table and computing the result in another table. So that's exactly what it is. You can go
So,
ahead, Mr. Gbadebo.
Miriam,
No,
was I
that's
able to
very
answer your question?
yeah. That's very it's very very clear right now. Yeah.
Okay.
Thanks, Benga. That's
You realize that if you are very familiar with SQL, you realize that if you try to compute this, it's going to work, especially if you are not aggregating from the one side of the relationship. But what is going to happen is that it's just going to explode into your face because you have duplicate records everywhere. But here, it's not going to work except you are aggregating. And if you can remember, in our product table, I was aggregating with SumX. If I just try to say, okay, related table sales record, it's not going to work. It's going to throw an error. Okay. Okay, let's move on. Right. So if I go back to this guy, and you see that we have this circular dependency error again. And these are the columns involved. You can see that it's telling us that the product records product sales depends on the sales record sales amount, which makes sense. We computed that value from the sales amount in our sales records. And it's now telling us again that the sales record sales amount is dependent on the column. This column is the percentage contribution that we are about to compute. We've not even computed it. So logically, it doesn't make sense. Why would an existing column be dependent on a column that we're about to add? I don't know if you guys get that. And it's now telling us again that the sales record column, which is the percentage contribution we're about to compute, is dependent on the product records product sales. That makes sense. Why? Because we are using a related function to pick this value from product records product sales. So I think I have something that I'm going to show us, like a diagram that is going to, simplify this and we understand better. But this guy is still throwing error. What exactly do we do? How can we bypass this? Okay, can we try to bypass it? Because we understand that this is actually happening because of the relationship that exists between these tables and the calculations that we've carried out from the sales down to the product tables. Can we just create a new table afresh, maybe a calculated table that has the unique record of products and has the total sales? Maybe this error is going to go away. Let's give that a try. So instead of using this product records, we are going to be creating our own calculated table that will have something like this, that will have our product ID, our product sales, and it's also going to summarize these amounts so that we can now do establish a relationship between that table and our sales fact table and do a related, maybe this error is going to go away, right? So now do we do that? We can come to table tools, create a new table, and let's just call that product total sales or something, right? And to do that, we need product name, we need product ID. The ID is going to connect to the fact table back. So we need to summarize, we need to leverage a summarize. We are summarizing our sales fact record, right? I don't know why this guy is blocking it. Okay, we can. Then because this has a many-to-one relationship to other table, we can also leverage that, which we are going to be doing. Product record. Let's pick product name first. Then we'll also pick product record, product ID. All right. So we've been able to summarize this, but I'm going to use a add column to just add a new column to give us the summary of that, let's call it product sales amounts or something, and let's just sum the sales record sales amount up. And I think they should create a new calculated table for us. Yeah, exactly. But something strange happened. It's not giving us the right value. We need to change that context. And how do we change this to a filter context? We leverage calculate. Then with calculate, it's going to give us the right value. Exactly. Now we have a new table in our data model. If you go to our model view, you see product ID that can actually reference the product ID in our fact table in the many to one. Voila. So instead of leveraging this particular the existing product record, we can just leverage the one we calculated ourselves. If we go back to the sales table and we want to compute our percentage contribution again, instead of us doing related to the original product table, we want to do it to, what's the name of that product again? That table again, product table, product record, and what's the name of the, okay, I think I'm referencing a wrong table. Products, what's its name? Product total sales. Product total sales. And then we have that one that we computed. It means we do not need this guy again. Right. And there's an extra parentheses. And when you do this, it's still giving us circular dependency error. It means we cannot outsmart Power BI data model. We need to solve the problem from the root. And how do we solve the problem from the root? Let's go back to this column. You know, while I was explaining context transition, I said when you use calculate anywhere at all, whenever you're computing a calculated column, context transition will happen. And the way it works is that the sales amount table, the sales amount column that you created with the help of calculate is going to be dependent on every other columns in that table, existing or about to be computed. I don't know if you get that. Now, the reason why it was giving us that prompt that the sales amount is dependent on discount is because the discount amount is now part of the table. So sales amount is now dependent on every other columns and the discount amount that you're about to compute. Hence, the circular dependency error. So we need to resolve this. And in my slide, I made mention of something that in order to do this, we need to leverage some calculate modifiers, such as remove filters, all except, we have many of them. We have all, we have all no blank rules and all of those guys. They are calculate modifiers. You can use them to modify the existing filter context. And because the use of calculate or context transition has made this sales amount column dependent on every other columns, including the ones that we're about to compute, we need to get rid of that. We just need to ensure that this column is dependent on one column alone. And that is the column that uniquely identifies every transaction and is a sales ID column. In a situation where we don't have a sales ID or a column that uniquely identifies every transaction, please don't try to use calculated column in that scenario because it's going to compute wrong figures, right? But we have it here. We can leverage this. And how can we leverage that? We are going to be using all except. Now, all except, like I said, is a calculate modifier. And how does it work? We're going to use it to change the existing filter context into a final filter context. And how do I mean? We've computed this, and this column is dependent on every other columns existing or about to be computed, right? And we need all except. And I think I said I have like a diagram that explains this better. Let me just pull that so that we can understand this better. I'm sure we can see this Excel table, right? I mean, Excel spreadsheet rather.
Yes.
Okay, great. If you look at this, each of these represent the columns from here, from this discount amount. Let me remove this guy again just to try to compute it. If you look at these dependencies, I'm going to copy these dependencies. I'm going to copy it and bring it into the Excel. Let's just put it somewhere here. If you look at the dependency, let me just bring it here. You see that sales record sales amount is what we have here, right? What the diagram is telling us is that it is dependent on sales record discount amount, which is this guy that we're about to compute, right? And this also is dependent on the sales record sales amount. This is also dependent on this, which doesn't make sense. That forms a circular dependency, right? And what we need to do, we don't have to make it cyclical. Because it is cyclical, as you can see, this is a cycle. That is a circular dependency. This depends on this also depends on this, and this now later depends on this. So the Power BI engine gets confused. Because it is cyclical, it's going to throw that circular dependency error. So we need to break this loop between these two. And that is what this second table is all about. We need to break the dependency between this and this here. And the question is, how are we going to break this loop? And that's exactly with the use of the calculate modifier called all except. Do we understand better what circular dependency is now? This new table that we're about to compute is dependent on this table. This table is dependent on this, and this is now dependent on this as well. So it forms a cyclical relationship between the three tables. So that is why we are getting the circular dependency error. So what we need to do is just to break the dependency between this table, and we are going to be fine. And every error is going to go away. Do we get that? So let's go back. Now, I'm going to put this back. So just going to comment it out again. And I'm going to come back to the original sales amount. And what we are going to do is to say, oh, Mr. Calculate, we want to remove filter from every other table. We want to remove the dependency from every other table except for the sales ID column. And so we are going to leverage all except. All except is very powerful. If you are familiar with SQL and you find yourself in a position that you have to compute, you have to use Windows function to compute maybe the total for a particular product in your table, you use overclass and your partition by and all of those things, it works exactly that way, right? So all except, what is our fact table is our sales record. We want to remove filter from every column in the data model in this table that we've referenced, except for one column, sales ID. So if we type sales ID, sales record, sales ID, right? And we close that parentheses. I think we should be fine now. It's not going to change. Nothing is not going to change. The computation will still be there. But the reason why the all except is there is just to remove filter from every other column existing or about to be computed except the key column, which is our sales ID. I think with this, we'll understand this. So that is why we now removed every filter from the table, all the columns, except for the sales table. And when you compute this, we are going to be fine. If you go back to your discount and you try to re-enable this, compute that, you see, finally, we have that error go away. So that is the solution. And that is if you must use calculated columns to compute your calculations, right? Someone is raising his hand or her hand. You can go ahead with your question.
No, sorry, that was a mistake.
Okay, all right.
I was
Awesome.
going to clap my hands.
Okay, all right, great. So that is exactly how you can override circular dependency errors, the use of all except. And to be honest with you, if I was to do this, I'm not going to be creating calculated columns all the time. And if I have to create calculated columns, I can easily go into my Power Query upstream to perform that calculation. And better still, if I have access to the database itself, I can just compute my column sales amount from there. And as a matter of fact, you don't need to compute it in Power BI. You can just create a measure and leverage your SumX, and it's going to iterate over it. And what is going to suffer is your formula engine, because we have two engines in Power BI FATIPAC, the storage engine that deals with the storage, the size of your data model, and your formula engine that all these formulas actually use to compute the final output, right? So that is it. And if you want to do the percentage contribution as well, I think we were referencing, let's now reference the original, let's reference the original product ID that we ingested into our data model. That's sales. You now see that we have for each of the products, let's take product ID 1 for instance, we now have 6,500 everywhere. It means that if you want to perform a percentage contribution, we can just divide the sales amount by this total for each product. We can quickly run through that. We can also leverage a divide function here. I just want to divide my, let me expand this so that I want to divide my sales amount. My sales amount is going to come first by the related total sales. So if you have this, we have it in, so we have to multiply that by 100, obviously, because we are computing a division, right? So you can see this one is giving us 18%, 51%, everything must sum up to 100. And if you add these three, definitely that is 100%. So if you want to add percentage in front of it, it means you're going to have to format it into text, and which is also risky because you might want to reference this particular column in another calculation. But if you want that, you can always do that as well, just to leverage the format function to say, okay, I want to format this guy in maybe in 2 decimal places and put a percentage. But that is going to change it into a text, as you can see. Obviously, we don't need this 100 again because we are just formatting the division between these two columns. You can see 18.5, 50.8, and 30.8. So that is it about circular dependency. As a matter of fact, I would not advise us to create multiple calculated columns. But if we must, we have to be wary of the usage of calculate. And if we need to use calculate, always have it at the back of your mind that calculate will ensure that the column that you are computing creates a context transition. And that context transition in that calculation is going to mean that that column is going to be dependent on every other columns in your data model. And in order to avoid circular dependency error, you can leverage the use of all except and remove the dependencies from every other columns existing or about to be computed, and just limit it to one column, the unique column in that table, which for this case is our sales ID. So whatever calculation you want to compute them upstream in your database or data source, or you can leverage the Power BI engine to do that before you now load the transformation back into Power BI. So that's going to be my advice, right? Wow. I think I went off for a few seconds. So that is going to be my advice. So finally, before we start asking our questions, I'm going to okay, I'm just going to wrap this up. Okay, then we can go to the key takeaways. And we now, after everything that we've discussed, I believe we now understand what circular dependencies is about. Circular dependencies can occur due to calculate in calculated columns. Avoid the use of calculate, and if you must use it, always leverage the calculate modifier called all except to remove the dependency of that column on every other columns in that table, right? And always ensure that the relationship between tables are unidirectional. So one to many, pointing from the dimension table down to the fact. And we also looked at the solutions, breaking the loops, simplifying relationships, leveraging the use of measures instead of calculated columns, and as much as possible, avoid calculate in calculated columns. Best practices, leverage the use of star schema, prefer measures over calculated columns, avoid referencing, avoid self-referencing, talking about column self-referencing now, validate relationships, and test incrementally. So if you are building your data model and you are establishing connections between tables, always test as you are establishing those connections. That's what test incrementally means. And finally, we can all practice identifying and resolving circular dependencies in our Power BI data model. So that will be all from my end. Thank you. I'm up for questions. Thank you for having me once again, Binga.
Wow, wow, wow. Thank you so much. This has really been very exposing, and I believe that people have really learned a lot. And with this now, they'll be able to improve their data model and understand when to use calculate, when to use iterating functions, and when not to use. At what point, what are you trying to achieve? So, guys, if you have any questions, please ask your questions now. Today is still here.
Please,
We have
I do have a question, please.
Okay, please go ahead, please.
Okay, thank you so much, Mr. Babatunde, for this awesome presentations and knowledge shared. Thank you. So my question is, the data model that you used, the relationship is a snowflake relationship, right? So now, can we change it to a star schema to rectify the circular dependencies, or do we have to do it just the way you showed us?
Okay, if you look at, let me just share. If you look at the model, if you look at everything we've done, you realize that we did not even make use of the product category at all, right? But
yes,
as your data model becomes bigger, it is critical that you flatten multiple dimensions into a single dimension. Like I said, Power BI runs on an engine called Vertipack. And the Vertipack engine is optimized for star schema data model. Right? So if you are going to ensure performance of your data model, it is very critical that you flatten these two into just one two table, and that is very easy. You can go into your Power Query, for instance, go into your Power Query, join the two tables together, and let me just, for instance, these guys are related. You just want to bring the category
you are
into
seeing
the
your
product
PowerPoint
table.
slide, not
Okay, I still see
the
my
Power BI.
PowerPoint. Oh,
Yes.
sorry, apologies. Let me just quickly reshare that. Okay. Well, can we see my model view Power BI now?
Yes.
Okay, all right. So what I was saying is that because as your model gets bigger, performance issues or bottlenecks start setting in, right?
Yeah.
And if you have multiple dimensions that can be joined together, that can be flattened into just one table, just do them. Like I said, this is a snowflake data model because we have a product table and we have a product category table separately. We don't need that. We can flatten the two together, and to do that is very easy. All we need to do is just do it upstream, right? Either in our database. If you do not have access to our database, we can do it ourselves in the Power Query engine by just merging these two tables together into a new table. By just saying, okay, I want to merge these two guys, merge as new, and I want to, merge together. They both have category ID, and you can see. And if you have this, all I need from this table is just the category name. I don't care about ID. And you see, we now have a new dimension table, right? Category ID already existed, and that. So we can rename this guy to, let's say, dimension. Dimension product. All right. And we no longer need this product category. We can just say, okay, disable the load. We don't need it to load. Even as a matter of fact, we don't need this product table as well. We can disable load on this guy as well. Then what's going to be loaded into our Power BI data model is just going to be the fact table, which is the sales record, and also the new dimension table that we just created. And when you click on close and apply, it may throw error because I think that is existing, but we might be lucky. Okay, I think we are actually lucky. So you can see these two guys now are what we need. This is the calculated table that we created. Just going to delete it from our model. And you can now see that we only have two tables rather than three tables. So if you want to analyze by category, it also exists on this table. If you want to analyze by product, it also exists from this table. As a matter of fact, we don't need the category ID as well. So we can just limit it to these three: product ID, product name, and category name, and that will be all. So if you come into our Power BI data model, we can run our analysis based on those two columns. Just come to the product, give it a product name. We want to summarize this product name. I'm not going to be creating any measure. Let's just create it by this. I want a table. You can see that. So if we duplicate that, we can always change this to a product category, and you see everything is going to be computed properly. So that is how you can do it.
Got it. Thank you so much.
All right, you're welcome. Any further questions?
I don't have any question from my side. I just want to say a very, very big thank you to you thank you for the wonderful delivery. You made it so simple. Do you have a YouTube channel or?
I don't, but Benga does, right?
Yeah, I
if
know.
you're
Yeah,
asking
Tunde,
about
this is a call
maybe
for you to
this
go and start a
particular,
YouTube channel.
I'm telling
I
you,
don't
your
have the
delivery.
time
I
right now,
mean,
to be
I've
honest.
seen a lot of YouTube videos on so many topics, and they always make things complicated. I'm not referring to Mr. Gbenga. Mr. Gbenga is good as well, but trust me. I mean, go and start the YouTube for real.
I would think about that. I don't think I have that time at the moment, to be honest. Thank you for the compliment, though. Yeah.
Is there any other questions, guys? Before I want to tell you something before you go. Any question?
Not question, actually. Thank you, Mr. Tunde. Can we get like a record of this? How can we
Yes,
get
it's
that?
going to be on our YouTube page, sir. I'm going to post it on our YouTube page. Maybe in the next 1 hour, it's going to be there. Yes.
If possible, if we can get the like the data he used, like we can still replicate it on our own.
Oh, okay, nice. I'll
Not
ask
a
him
problem.
to do that. Yeah, thank you, Tunde. Thank you so much, Tunde. You're highly appreciated. But before we go, I want to quickly show you guys something. Let me share my screen. In just few seconds before we go. So, we are happy to announce the Winnipeg Power Platform User Group. We're happy to announce that we are going to be hosting the Global Power Platform Boot Camp. This is going to be the first of its kind in Winnipeg. This is a boot camp that is organized throughout the world in different cities of the world. So if you go to the Microsoft Power Platform Bootcamp page, you are going to see that Winnipeg is now a registered center, which is part of the global bootcamp going out in different cities, going on in the rest of the world. So we are happy to announce this, and we have our course for speakers. So if you are interested in, being a speaker, you have a topic in mind, just like today has done today. You have something interesting. Maybe you were working on a project at a time and you discovered a problem and you were able to, solve that problem. You can come and do a demo for us. It's going to be something very interesting, and you are going to be recognized, by Microsoft. We also have the participant registration link also showing on your screen. You can do a screenshot. I can send that to your email at the end of this today's section, and we have the link showing on your screen. So you can just do a snapshot of this. You can see the call for speaker link and also the participant registration link. So guys, thank you very much for staying by in today's section. You are highly appreciated. We appreciate the speaker who has stayed long to really dive into the topic. I really gained a lot, and I'm also going to even rewatch the video again just to enhance my own understanding of how I understand circular dependency. Thank you very much today. Thank you very much everyone for staying by. See you again in our next session. I'm going to update you on when that is going to be. Probably that's going to be after the Global Power Platform Bootcamp. So I'm going to update you guys. Thank you so much. Have a wonderful weekend. Have a wonderful day ahead. God bless you.
Thank you, Mr. Gbenga, for making this possible as well.
Thank you. Thank you, everyone. Bye.